Welcome to Down Ancient Trails, the online archaeology forum of the Sharma Center for Heritage Education, India. Brush the dust off long forgotten thoughts. Slice through time and space.
Listen to stories in stone.
Whispers of voices lost in time.
Build bridges across worlds.
Curious minds reach out to the past. And travel down ancient trails.
Thank you, Shanti, for the introduction, for the invitation, and for running this fantastic endeavor. I've heard many Zoom talks. This is the first one I'm giving, so I hope it goes well, and bear with me, please. Also, I have to say that I'm currently in New York City, which, as you probably heard, is at unrest. So there may be noises coming from the outside, like the police sirens and the helicopter hovering above. So I hope it doesn't bother us too much. I closed all the windows. It's double paned, so I hope it's okay. During this series of talks, I think people who are repeating attendants heard a lot about very famous and very big and very important sites and research. And what I want to do today is introduce a completely, to the scientific community at least, completely new site, the site of Melka Wakena in Ethiopia, where I've been working with my student, again, Hugo Saaredo. More about him in a minute, and a group of other researchers for the last 5 years. So the talk will be structured more or less along these sections. I will provide some background to the question, then go to the site itself, the chronology and stratigraphy, talk about the localities that we excavated, a little bit about the lithic assemblages, some ideas and very few clues that we have in hand at this point about the paleo environment, some ideas and some hints about behavior on the landscape, and then get back to the question mark in the title of the talk. Could people take the high road out of the Eastern Africa region? So, some comments for context and background and what makes, excuse me, Melka Wakena interesting. So, just to clue you in as to where we are, Eastern Africa, Melka Wakena is basically a little bit south of what is known as the Horn of Africa. And this is an area that is geologically very interesting because it's one of the few, I think maybe the only one, triple junction where three tectonic plates are waving goodbye to one another, each in a different direction. And this is the triple junction, the Afar Triangle. And this affects everything that is happening in recent geological time on the plateau and along the margins of the Indian Ocean and the Red Sea. And so here we are looking at some of the known archaeology. A lot of this you heard already in previous talks in Africa. And you can see they are arranged or marked and symbolized according to mostly the dates. I'm not going to go into the discussions about developed Oldovan versus Acheulian versus Oldovan and so on. So basically looking at the dates available, we have 2.6 to 1.8 million years ago. The red circles, sites from that time period in Tanzania, in Kenya, in Ethiopia. We have the 1.8, 1.75 to 1 million period, the yellow rectangles. Then we have the later or the classical Acheulian. And then marked by the stars is the site of Melka Wakena in the midst of all this. And you can see by the colors, we will be talking about, oops, I think it's a mistake here. No, it's okay. We will be talking about the early Acheulian, or the 1.8 and the 1 million time span. This should have been yellow, not red, sorry. And looking at this map and this distribution of sites, we can see that what we know and what we think and what we contemplate about the early evolution of humans in terms of biology, in terms of culture or material culture, is influenced by what we know from the rift, from the environment of the rift, from the sites in the rift, from the fossils found in the rift. And a lot of our questions about and our thinking about these issues are formed by the affordances, what we know from the Rift Valley. And we know very little from our other places. There's a bunch of sites down here in South Africa. There are some more now, and I think you heard about Embusherit probably some time ago, and some other sites in Northern Africa, but it's still mostly the rift that formalizes and influences our thinking about these issues, including the many fossils found and the way that hominids moved out of Africa. It's all concentrated on the rift. Obviously, some of it is an issue of research bias. People have been going to work in the Rift Valley because it's well known. There are many sites, many known fossils there, and people are hoping all the time to get more. It's also an issue of archaeological visibility, a lot of barren landscapes, so it's easier to locate sites, it's easier to locate the fossils. It's also an issue of reality. It's a relatively low area. We'll talk about this in a minute. And it's a sediment tract. So there is a lot of sedimentation and there's the probability of finding stuff in there. Whereas in the higher areas, sedimentation is not always so great. The likelihood of finding good sites and of finding interesting fossils is lower. But still, I think people have not really looked to the higher elevations. And this is a map showing specifically Ethiopia now, looking at sites that are located on the highlands. They are marked here with the red sort of crosses. And you'll see there are 5 of them in the whole of Ethiopia. And this is it. I mean, there are no other known sites, or at least published sites, in the highlands of Eastern Africa outside of these 5. And I think in the whole wild world, there's maybe another one in Kona, in the Republic of Georgia, of all places, that is early Pleistocene site that is located at the elevations above 2,000 meters. So when we look at the sites, in Ethiopia, I'll just go very quickly from north to south. There's the site of Chilga that was reported in the literature with a report on the fieldwork, on what was found, which is Acheulian indexes, but there are no dates and there was no follow-up publication that I could find at least. So we know there's a site there, but we know very little about it. There's the site of Fanta, practically on the outskirts of Addis Ababa. So again, all of those are 2,300 meters above sea level. And Fanta was reported geomorphologically, and fossils were mentioned, but there was no descriptions of the fossils. And the archaeology was not referred to. I think there should be archaeology, but I've not seen anything. I was at the site many years ago, I didn't see much, and nothing was reported. The recent addition to this is Mount Dendi, that Ralph Vogelsang published 2-3 years ago, but this is not early Pleistocene. It's dated more or less rigorously to about 300,000 years, and it's really high. It's about 3,000 meters, 3,000 meters above sea level. And the best known up to now are best known and excavated and published sites are Melka Kunture here, and the site of Gadeb right here. Melka Kunture is still being excavated and studied, and there's been quite a number of publications on it. It's a long sequence. Some Oldovan assemblages, some stuff that is apparently older, although there are some debates about the dates, older than 1.5 million years ago, and then there's 1.5, 1.4, and sites that date to the mid-Pleistocene transition, more or less. And the Gadeb site that Desmond Clark worked in and published on has some dates, again, putting it at around 1 million years ago. And this is a site that is currently unavailable for study because it's underwater due to some hydroelectric dam that is just right here. And Melka Wakena is about 10 kilometers south of Gadeb. In some ways, you could argue that this is the geographic continuation of the Gadeb site. And Melka Wakena is available for study, but it was not known until 6-7 years ago, when a group of researchers came to look at the site. So if I'm trying to think, what are the possibilities on the highland, just given the, looking at the rift, looking at the highlands, I just did this exercise with Google Earth. You look, here is specifically went to Kenya and not to Ethiopia, and looked at the area of West Turkana, where many famous sites are located. And here is Turkana Lake, and these are the Kenyan highlands, 1,732 meters, the highest point of this totally random transect. And you can see that from there we have a very steep escarpment and a very gentle slope towards the center of the rift, and this is the sediment trap that is the rift that provides the possibilities for our kind of research. When you move to our area, Melka Wakena, the city of Asasa is our base of operation. The site is just to the east of it. And you can see here the Bale Mountain, 3,981 meters. I picked the peak, or very close to the peak. There are obviously lower areas. And if you do the same thing, you see a very similar thing. There's a steep escarpment, then there's a very wide and gently sloping floodplain. And the difference is that here there's still another drop into the Rift Valley. So this is kind of an intermediate step, but this can also serve as a sediment trap, and where sedimentation can occur. And this is where we might find sites on the highlands in configurations like this. So admittedly, the Bale Mountains are not everywhere. And this is kind of the white plain, what we call the Gadeb plain. This is the unofficial name that we gave it. So the Gadeb plain does not occur everywhere, but if we can find places like this, this might be a good place to look for sites. The stars in each diagram mark Melka Wakena. This is more or less the location of Melka Wakena and of Lokalili, one of the Turkana sites. So just to show that there is less maybe a potential to the highlands, but there is potential that should be modeled more carefully and probably set the parameters of search for the sites. So again, just to clue you in, what's going on? My computer decided to be very sensitive and responsive. Looking at the close-up of the triple junction, the Afar Depression, the Arabian plate that's moving to the north, and then Somalian and the Ethiopian plate or the African plate. Melka Wakena is located here. This is the main Ethiopian rift. This is more or less the site of Melka Wakena. It is on the at the headwaters of the Wabe River that goes north, then turns to the east and goes south along the shore of the Indian Ocean until it goes into the ocean. So there's a lot of interesting geology there that is none of our concern at the moment. We will be looking at what is happening here. And before looking at that, I want to tell you how I got to know Melka Wakena, the site. And the first visit for me was on the date you see on the screen, January 2014, when Tegenu Gosa here and Jonathan Saleh here, we met in Addis Ababa. I was doing work on other things there, and they said, well, would you like to go and see a very nice site that we think is worth exploring? I said, sure. So we went to Melka Wakena, and they also showed me this to whet my appetite. And this is more or less what you see. This is the landscape. It's very flat. It's 2,300 meters above sea level, but basically very flat. The river is meandering and doing very crazy things. This is an island that sometimes the island, sometimes the land bridge. The water levels are obviously affected by the amount of rain, which is never small on the Ethiopian highlands, but also by the fact that it is on the blocked side of the dam. It's behind the dam, so depending on the requirements for electricity, you get more water and less water. So there were seasons when we came to excavate some specific sites and we found them completely underwater. And we couldn't excavate, so we had to develop plan B for the excavations. That happened too, but all turned out, I think, to be interesting, if not good at least. So we had the river voyages and crossing in leaky boats. This is unfortunately as much as the wildlife that you can see. It's a very heavily populated area, and the wildlife was hunted down for food and also to prevent damage to the crops. There's a lot of interesting geology that needed to be figured out to understand what's going on. And there are stone tools and there are fossils in many different shapes and forms and contexts. So it seemed like a very interesting and promising site, and given all the issues that I just explained about how very few sites there are on the highlands, it also seemed like if we could start a project, it would be a good contribution and something that could advance our knowledge about whatever period we were going to find here. Because there were some sites already known from the highlands, there were, in the literature, you can find several hypotheses trying to explain the occupation of the highlands. I tried to agglomerate them into three groups. There are not so many, actually. So one talks about geographic expansion. That's a seasonal movement back and forth between the rift and the plateau, which is quite a large distance. And that's an idea that was developed by Desmond Clark and Hiro Kurashina based on raw material. They thought they identified some movements of raw material, and they saw also similarities in the stone tools, and they thought that the way the plateau assemblages were preserved suggested that they actually represent a mirror image, basically, in terms of mobility and settlement and intensification compared to the rift. So in the rift, sites would be short-lived and also would be heavily affected by erosion because they are at the base of erosion. Whereas sites, if you do find sites on the highlands, they would be better preserved, although also affected by erosion because there are channels obviously there too. Later on, Desmond Clark discussed the option of what I would suggest, he did not call it that, I don't think, niche expansion. So it's not just a geographic expansion, but also hominids broadened their dietary breadth. They ventured into an environment that offered different resources than the rift sources. And so the occupation of the highland represents a broadening of the resource base. For all these ideas, the rift is taken as the source area, and I think justifiably so based on the dates that were available at the time, and this is still correct now. And I think the most recent formulation of the idea of rift highland mobility was by Margarita Mussi some years ago, where she suggested that the occupation of the highland was periodic in the sense that it could happen during interglacial times when it was not so cold on those lofty peaks. Whereas during colder times, hominids could not, that would be Homo erectus sensulato. This is who we think lived on these sites. There are some remains in Melka Kulture. We did not find any yet. So Homo erectus could not live at those elevations during cold times and had to migrate back to the rift in order to come back to the highlands during warmer periods. So these are the three ideas that are in the literature, and obviously they can be discussed with new data and new questions that target specific elements of these ideas. In our project, we haven't reached that particular moment yet, but we are getting there, I hope. So basically, this is our team, that people that came to the field for 3 seasons. The geology team is Asfawase Nosrat from Addis Ababa University and his student Angesom. Bienvenido Martinez Navarro from IFES in Tarragona looks at the paleontology. Paul Rennie and Elizabeth Niespolo are in charge of the dating. And then there are the people who excavate. So we had a bunch of Israeli students and researchers and a bunch of Ethiopian students and researchers helping in the field. I'm happy to say that Angesom wrote his master's on Melka Wakena, and that's already published. And Tegenu is my partner in crime, so to speak. He's the co-director of this project, and he just submitted his PhD on the lithics. So I will be relatively brief on the lithics, and I think he's giving a talk in our seminar in Jerusalem tomorrow. So if people are interested, get in touch with me or with Shanti. I think Shanti also has the link, and you can try and join in. These are the people who did the magic. We had 3 field seasons, very short field seasons, maybe 3 weeks each. And then for Tegenu, at least, it was 5.5 years of very hard work until he finished his PhD, I think very nicely. So looking at the sites, finally, the sites themselves. This is the research area. As you can see here where we are located in Ethiopia. You can see the close-up of the area. This is Asasa. You already saw it on one of the previous slides. And this is more or less where we are working. In terms of the local geology, I will be very brief because this is really not my expertise, but I would say that this is an area that is under very strong influence from the activity in the Rift Valley itself, which is down here where the lakes are. Most of the most recent uplift, tectonic uplift, is during the Pliocene, 5.2 to 2.6 million years ago. And this resulted in the formation of silicic volcanoes in the rift itself. You can see this one here and this one here and many others. You can follow, these are the signs for them, here, 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 and so on. And following that, or synchronously with that, there was a lot of deposition of pyroclastics on the rift shoulders where we are, about here. After that, there's another phase of faulting, not so much uplift, but faulting, just at the time it is of interest to us, 1.6, give or take, million years ago. At this time, there's a lot of volcanic activity from both the shield volcanoes that were formed previously on the plateau, this one and this one. These are just overlooking the site. There's a lot of flows of rhyolites and basalts and ignimbrites that you can see covering the shoulders of the rift, whereas the pyroclastic material, the smaller tough tephra, is probably coming from the spews of the volcanoes in the rift itself. So there, in Melka Wakena, we find the distal tephra and very proximal basalt flows. And this constitutes, this later phase constitutes what we call the Dino formation, and the sediments of the Dino are the ones in which the archaeological sites are found. So a view of the Wabi River in our research area. These are localities. This is the village of Aluba. I think nearly every male above 13 years old participated one way or the other in the excavation. So this is a time to also say thank you to the villagers of Aluba and to the people from the town of Asasa for all their help during the time we worked in the field. You can see the scale here. It's not very large. This is 500 meters, so it's not a huge distance, but you can see how the river meanders and how the sites are found along the river. A close-up of this. What we see here, I'll just mention it because it will be important to understand the context. What we call the upstream and downstream sections. We did this division for the sake of the geology because while we could correlate geologically sections across here, and we could correlate sections across to one another across here, we are not sure yet about the correlation between this part and this part. So we are separating them. 10 localities that were identified. I should say that we know that there are localities also on this site, but we have not yet worked here. So 10 localities, among which we have quarries that are the target of the next field season, whenever that happens. We have excavated sites. These are the 3 sites that were already excavated, and I will talk mostly about those. And we have some sites that are mainly paleoanthropological sites, this one here and this one here, which started the whole story of Melka Wakena, because this is where the villagers of Aluba were quarrying for sand and found some fossils of big bovids. Turned out that they were late Pleistocene, not early Pleistocene, but that started the whole thing going, and this is why Jonathan and Tegeno knew about the site and came to me to see if I was interested in joining them. So this is the setup in terms of the geography and the sites. Just to show you a very general, as I said, upstream and downstream scheme of the geology. I'm not going to go into the details, but just to let you know, or to show you, that we are talking about sequences of fluvio-pyroclastic deposition. So a lot of conglomerate, a lot of sand, a lot of tephra, all mixed up. Some of the tephra are from windfall, some are transported by water, but this is the nature of the whole sedimentology in the area. And this is consistent with what you would expect from the Dino Formation as it is now in other places. You can see that the view is not the same from one side of the river to the other. And as I said, we are still missing the link to connect them. And I'll say a little bit more of that later. The dates provided by Elizabeth and Paul. Again, I'm not going to go into all the details that they provided, but I want you to see the following. We have some dates from some samples. The colors here marked, obviously, the dates that you have here. Some of these dates are really, really of good quality. So they provide eruption ages. This is the age of the tephra as it erupted. The statistical certainty is very high. And so this is really stands out, but you can see the same here, and the same here. So we have 5 like this that are eruption ages. Oops. And as opposed to this, we have others that are multimodal. So they are not pure in the sense that it's one eruption, but it's probably stuff that was transported by water and accumulated older and crystals as well. So we are using the younger, it's all single grain. So we are using the younger ages as the maximum age of these sediments, of these deposits. And when you put it in context, so this is what I say, primary ashfall along the river from the volcanoes in the rift, 5 of the 9 dates that we have. The other ones are less secure in the statistical sense, but the dates provide maximum and minimum ages, respectively, for overlaying and underlaying materials. So the archaeology is sandwiched between good dates. Most importantly, even the second kind of dates, the multimodal dates, maintain stratigraphic order in the stratigraphy where they belong, with the tephra that have eruption ages. So taken together, we have quite a strong constraint on the chronostratigraphy of the excavated sites. And there you have it. So the area of Melka Wakena 2, these are the 3 excavated localities, Melka Wakena 2, 5, and 1. At Melka Wakena 2, we have 4 dates. And as you can see, they are very nicely aligned stratigraphically, and they very nicely bracket the archaeological sites, the archaeological localities that we have observed so far. I should say that the logs, the sections are from the water level. So we know already that there are older deposits underwater, but we are unable to access them. We don't know if they have any archaeology or not. So this is MW1 with a nicely constrained section. MW5, see that these 2 are the same age, basically. And then we have some other dates here as well that help us to constrain the later archaeology. There's some archaeology here that we did not excavate. We focused on that. And basically we can, only by the dates, we can draw correlations between these 2 sections. The sediments support this correlation, or they're consistent with the correlation. MW1 has 1 date that caps everything that is archaeological, and it's mid-Pleistocene, as you can see, but all the sites are farther below, and I will go into this in detail later. So this is how we stand in terms of the chronology, and our reading again is that even this site should be at about 1 million. So we are looking at 1.6 to 1 million. And basically 3 periods of occupation. MW5 Unit 1 and MW2 Unit 1 are the same age, the same here. So this is 1.6. Here we're looking at 1. I would say 35. Sorry, 1.4. This is one. Again, another correlation that can be made. Oops, we can go back. It's not going back for some reason. Okay, one more. All right, so this is one correlation. So these are probably of the same eruption. Another one here that is probably of the same eruption. And this is a later, an unrelated to the archaeology at 1.25, which again probably suggests a third eruption. So we have 3 specific eruptions, 2 of them also correlate to the archaeology. So moving on to the sites, I'll go from older to younger. Melka Wakena 2, this is the general view of the site. No. Sorry. Okay. So this is the section specifically of that site, and you can see here. You can see here the cliff face with the units marked on it, correlated to what we see here. The archaeology, or where we excavated what we saw in the previous slide, is just up here. And this is what the layer looks like. It's 13 square meters, and it's basically a pavement of stones. And our first thought, of course, was that we are looking at something that was partially geogenic, transported by water, but this is not necessarily the case. This is the same in a map, 3-dimensional. Of course, not everything is here. And a vertical view, a profile, you can see the layer. It's about 20 meters thick with a very specific concentration, as you can see here. So this is layer 3. And we have another layer separated by quite a lot of sediment, layer 4, which we only excavated 4 meters of. These are the numbers. So quite a lot of lithics in layer 3. Oh, I'll start with layer 4. Layer 4 is small, very few lithics, relatively a lot of bones. So it looks very different from the very restricted window that we have, looks very different from the layer above. Layer 3 is, as I said, a pavement. And you can see out of the 7,000 artifacts, 86 lithics, I'm sorry, 86% are artifacts, so modified one way or another by humans. So it's not a geogenic deposit, but mostly anthropogenic. MW5, high above the water. This was our plan B one season when we couldn't excavate MW2, for example. So what we saw when we started the excavation was what you see here marked in red, just the handexes and cleavers and flakes sticking out of the section. So we picked this place because it seemed like a good archaeological layer, also because there was some work done by the sand quarriers from Aluba village. And so there was relatively less overburden to take down. And this is the stratigraphy in photograph and in section. So again, you cannot see in this photo, you can see Gadi. This is not seen in this photo, but you can see here archaeological layer 2 and archaeological layer 1 here. And these are the units above. And you can see how they are dated. And the sediments are the same. It's sand, it's conglomerate, and the ashes intermingled with them. This is a map, a joint map of the two layers together, basically 10 square meters, above 2,000 artifacts, most of which are indeed artifacts and not just transported stones. So this is layer 2, and on the left you can see the map of layer 1, very, very different. This is not a real, very different in terms of the distribution, the density, and also the stuff that you find in there. And this is full of cleavers, handaxes, large scrapers, and so on, and some bones, quite a number of bones. This is what it looks like, and when we excavated this, I sent Nama the photograph, I think from Asasa by very slow email. And the first thing she said, it looks like two different things. And I said, Nama, you have a fantastic eye, because that she figured it out from a crappy photograph over email from Asasa. That was amazing to me. I think we are looking at two different things, although they are on the same surface. They are lying on the top, on the top of a tephra layer, so an ashfall. What we see here are a lot of artifacts that are flat, lying in situ. And somewhere here, there's a change in the mode of the position that we see now, and it's jumbled and mumbled, and there's the same stones and the same type of artifacts with a lot of bone. Everything is crushed and jumbled and lacks orientation and stands on end. So there's something here going on, and we actually are looking at, we think, a lateral contact between, or we are looking at a place where there must have been some water flow, probably in this direction, that cuts through the original layer, which we call 2LB, and redeposited the same stones with potentially others that were brought with the water in a very unorderly fashion. So this is the original, as we understand it, layer 2B in Melka Wakena 5. This is the direction of the transport. And all these artifacts were removed and redeposited, some of them in place, and some were probably transported out of the site at a later time. So it's the same assemblage, but it's not the same integrity of the assemblage. MW1, a completely different story. This is actually the first thing that you see when you, that you are shown when you come to Melka Wakena. You can see here the location of the site. This is the ledge, a very hardened ledge. And when you look at the components, nearly all of them are bifaces. So cleavers or handexes constitute mostly all of this. And there were obviously some others, many others over here. This is the very favorite tray for the donkeys and the goats, so it's not very well preserved, but we found a lot of stuff rolling on the ground below. As I said, we don't have a date for the site. We have a minimum date for the site, and we think that it should be, these are the archaeological layer, B and A. This is the one we showed before. There's another one just at the bottom of this, separated by this small conglomerate. So both layers are well over a meter below the date, and we ballpark the age at about 1 million. But we don't know yet. We are trying to figure this out, maybe with paleomag or some other methods like this. This is the ledge you saw before. We dug a little bit. We saw a continuation of what you'd call a archaeological layer B down at the bottom here. There's a channel cutting everything, a recent channel cutting everything here. This is the northern edge of this exposure. So we tried to go to a undisturbed area to excavate and see if we could figure out stratigraphy and where the in situ layers and how they are correlated maybe with this. And this is what we found. So this is 0.5 meter, another 0.5 meter, a meter below the present day surface, which means very little in fact. This was sterile archaeologically, and we started finding things here And you can still see here what we call step 4 in situ. This is step 4. The stuff is in situ. You can see it looks exactly like the ledge. It's not the same thing, but I think it's another similar phenomenon, but it looks exactly the same. It's simply packed with the artifacts, and a lot of them, you can see the numbers here, many lithics, a lot of them are artifacts. So we have 3 different sites, we have 3 different contexts of the position, and let's look at the archaeology. And a lot of this is based on the work that Tegeno has just finished. So first of all, looking at the densities, these are the older sites, this is the younger sites based on the dates that we have in the stratigraphy. And you can see that we have a lot of variation. It's not necessarily related to age. So it's not that older sites are less and younger sites are more variable, but also please bear in mind the sizes of the excavation. This is the steps here are from very few, less than probably 2 meters of excavation. So we don't really have good control of the spatial variation, the possible spatial variation. This is how the assemblages are patterned. We have cores in all the assemblages. We have a lot of flakes. MW 2 layer 4 is 25 items. These are in situ, so I'm just showing the in situ stuff. So it's included, but it's a tiny, tiny sample. Core trimming elements in all of them, more or less. The micro artifacts are interesting because you find them in some contexts, but not in others, which may suggest something about the amount of winnowing by water in these particular contexts. We have large cutting tools. There's actually a few here too, but there are so few that they are not shown in this huge assemblage. So some large cutting tools and some flakes related to the preparation and finishing of such artifacts in all of the assemblages. Percussive objects, as you can see more in this area than in Melka Wakena 1 than in other areas. So all in all, a representation for a lot of the lithic reduction, or all stages of the lithic reduction, but it has to be broken down more carefully. And what we observe are 2 reduction systems for each of these assemblages. The first, which is the majority, is the reduction sequence for small and medium debitage. So these are the cores, the smaller cores. They are usually done on welded ignimbrite, on other volcanics, and the raw material was probably picked from the river cobbles. And for these, you can see the full reduction sequence nearly from, well, basically from the beginning. So you have the core, the cobble picked up from the river, you have more cortical elements, you have the flakes, and it seems like the full reduction sequence with some emphasis, I will show it in a minute, on trying to prolong the use life of the core, but doesn't seem to be a burning desire. And this changes little, if at all, through time. A second system that you see is for large flake production, which would be for the LCTs. And in fact, I should say these, we don't see the production of the large flakes. We see the large flakes that were used for the making of the large cutting tools from the earliest assemblages. And here you see a preference for a very specific raw material, the glassy ignimbrite, although you do have large flakes on other raw materials. I'll talk about this in a minute. The source of the glassy ignimbrite is off-site. It's not in the Melka Wakena area. And most of the items that are made on this raw material are really related technologically to the shaping and finishing of the large cutting tools. And we would call that a fragmented reduction sequence. And this is something that you start seeing, I would say, from the later assemblages from Melka Wakena 2, Melka Wakena 2 layers 1 and 2. I will not talk about those a lot because they were not from a secure stratigraphic context, but we do know that they are late in the sequence. And the LCTs, they are on glassy ignimbrite, and you can see the finishing and the preparation and finishing and shaping flakes for the bifacial tools. This reduction sequence does change through time. So I talked about the raw materials, and here is the, I think, the very clear view. The details don't really matter. I realize it's a little bit small. The blue is the glassy ignimbrite. And you can see these are the cores and the debitage, and you can see that we have the glassy ignimbrite, we have the welded ignimbrite, which is the quarries or the workshops near the sites are of welded ignimbrite. This is what you see near the localities of Melka Wakena. And then we have another type of ignimbrite and some other very few rhyolites, trachytes, blah, blah, all organized as other volcanics. So cores and debitage are variable and would make sense. There's the glassy ignimbrite here comes from the riverbeds because it derives from a source upriver, and it comes in the form of cobbles. When you go to the handexes and the cleavers, I think it's very clear that the view is very different. A very large emphasis on the glassy ignimbrite. That would be, as I said before, the same for the flakes associated with the finishing of the bifaces. And it's very clear that we are looking at a very specific and very different mode of production, mode of thinking and mode of production towards making these two types of tools. And as I said, it is a fragmented reduction sequence. So these are the localities of Melka Wakena, and the welded ignimbrite is exposed along the cliff on the surface here. And as we said, this is something that comes from the volcanoes that are just probably just up to the north. We have to still check that this is indeed the source, but this is our going idea. The glassy ignimbrite is not available, at least is not exposed today, anywhere near the sites. And we do know of two exposures in the Kava River, which is a branch of the Wabi. And it seems, based on some petrographic analysis that we did, that this would be the source from where the glassy ignimbrite reached Melka Wakena. So some of it that was used in the small flake production reaches the area from the Kava or maybe other places through the rivers as cobbles, but the big flakes that were used for the handexes were brought into the site. They were not transported by the river. So people from here went there to to produce the flakes maybe and get the flakes and bring them here. Looking at the technology, this is the small debitage system. The analysis, again, this is the work of Tegenu, was done according to the Latour's organization of the cores. So basically we are talking about three types, I would say, of cores. Looking at the degree of rotation of the core while napping, if it's restricted or full rotation, so a full circle, so to speak, and the way that the volume was exploited, whether it's just the periphery combined with any way of rotation, or the full volume, so going into the central part of the flaking surface, so to speak. So these are the restricted peripheral, full central, so full rotation and an attempt to exploit also the central volume of the core, and unstructured cores, which counterintuitively are the ones that are most used, because they are so used that they really lost any structure. So that would be the discoidal and globular and things like polyhedral, things like these here. And you can see that with the small debitage, there are some examples here of a discoidal and of the full central rotation, something from this group that you can see here. So there is an attempt to use the edges of the core efficiently, but it's not a very extensive. So for the small debitage, we don't see a very clear or strong attempt to exploit the cores to the reduction, to the exhaustion. When you go to the large flakes, and this is based on what we see at the site. So this is not the glassy ignimbrite, this is the welded ignimbrite. We do have large flakes of welded ignimbrite, and less of those were transformed into bifacial tools. So we have them as flakes in the assemblages, but large flakes. And you can see here some of the cores that we see in the quarries. This is from Melka Wakena 6, I think. This is Melka Wakena 8. This is, I don't remember. And you can see that we have 3, or at least Tegen reconstructs, 3 modes of reduction. The side-struck flakes that are wider than they are long. The special side-struck flake, you can see here one like that, and the end-struck flakes that can be used. We can assume that similar techniques were used, or modes of production were used for the glassy ignimbrite at the source, because what we see at the sites are only mainly the flakes. So this may be more efficient in terms of the force, and Achilles may be able to maybe say something about that, in the terms of the force that you have to invest when you remove the flakes, whereas here the end-struck flakes probably are less economical in terms of the amount of strength that you have to invest, the energy that you have to invest in order to flake them. And at Melka Wakena, they went for the side struck and a special side struck in most of the time. So when you look at the large cutting tools, the indexes, more than 90% are on flakes, as you can see here. In the later assemblages, we have more items on cobbles. All the cleavers are on flakes, and most of them are side struck. Combewa technique, or Combewa flakes, appear as blanks for the large cutting tools from Melka Wakena 2, as I said, layer 1 and layer 2, and Melka Wakena 5, layer 2, so around 1.4 million. And I think, to the best of my memory, this might be the earliest appearance of the Combewa, but we have to go and check this again in the literature. So just to run very quickly of how the dynamics of the production, as I said, the large flake production and the index geared production is dynamic through time. So we have peaks. Date of first appearance in Melka Wakena is the earliest assemblages, 1.6. Date of last appearance, 1.4. After that, we don't find the peaks in any of the assemblages, and they are crude and they are big. This is 10 centimeters, so quite large. Other material from that time frame are the preforms, atypical bifaces, what have you, big, very thick flakes. Some we can see here were transformed into large scraper or giant scrapers or heavy duty scrapers, depending on which terminology one uses. We have typical indexes, again, the side struck flakes. I'm showing this because in that particular assemblage, especially we have fantastic variation in terms of the sizes of the indexes. So this one, this is 15 centimeters. This is about 30 centimeters in length. These are less than 5 centimeters, and some of them are very fully worked. So we have 1 or 2 of these and 3 or 4 of these, and everything else is in the middle, like this. But these are nicely shaped indexes. And then when you move to the latest assemblages, this is what the bifacial material looks like. And based on the work that Tegenu and Gadi and I did with 3D geometric morphometrics, we can show, or Gadi can show, that there's a lot of bilaterally and bifacially symmetrical investment in the symmetry, both bilaterally and bifacially. And this is really visible in the amount of finishing and retouching that you see here. And the cleavers, which appear from 1.4 more or less. Here is an example of those, always, as I said, on flakes. So for the cleavers and indexes, the raw material selection is identical, and the geometric morphometric work has shown, still in progress, but has already shown that they have overlapping, but still distinct shape spaces. So they can be distinguishing, even though sometimes they look similar or can be similar. The cleavers do not change as much as do the indexes. And they're always variable, more variable than the indexes within assemblage and between assemblages. And the indexes become, with time, less crude, more symmetrical. This is done by a lot of investment in the shaping, the removals, applied in a way that, by the way, both to the cobbles and the flakes, and applied in the way that it maintains the ratio of thickness to width and the ratio of width to length. So these ratios actually do not change through time. So there's an attempt through the higher investment to keep the indexes within a specific shape context or template, I would say. And I would just cite here the work of Herzlinger and Goren-Inbar, who I think found similar things for Gesher Bnot Yaakov, saying, which is a little bit later, saying that cleavers are the shape, or the working edges of cleavers are shaped mainly related to functional aspects. With the indexes, there seems to be an extra effort to maintain some shape idea that is not completely functional or not only functional and may relate to social aspects. So this is a nice complementary evidence, I think, or supporting evidence to their argument. In terms of bones, you saw that we don't have many bones, but we do have some, and at least in some cases we have anthropogenic marks on the bones. On the bones of hippos, I haven't talked about the assemblage yet. I will do that in a second, but I just wanted to show you the cultural use of the bones. So percussion marks on the bones of hippo, these are from MW2 layer 4. We suspect that maybe others in both that level and in MW5, but we still have to confirm them. And also maybe cut marks, but it's interesting, maybe it's related to the size of the animal, that we don't find the cut marks, but we do find percussion marks. And this goes back to some ideas about the evolution, if you want, of meat eating, of meat getting, or of getting resources of the animal. Some papers that have been published on the bone and in the bone resources and how they are patterned in time. Something about the environment. I will start with the present environment. This is from a website looking at the area of Assasa. And the discussion starts with the question, what kind of changes would one really expect at 7 degrees north? I mean, it's basically the equator. Well, it is, but if you have the physiography of the Rift Valley and the plateau and in some other aspects of diversity, it can make a difference. And the difference may not be necessarily or not big necessarily in the parameters that we usually think about. We think normally about temperature and precipitation. As one who experienced it firsthand, I would say radiation is a big issue because it's much more significant and can affect the biological sphere in a very different way when you go to the high mountains. It's very, very different. So you can see that there is not a lot of variation in temperatures throughout the year in Assasa, so basically in a Melka Wakena area. And precipitation does change. There are very rainy months. There is the big rain season and there's the small rain season. And I must say that whenever I'm in Ethiopia, it rains. So I think everything is one rain season, but formally there are two. It's B model. And every month you get some rainy days, as I just said. But obviously there's a bimodal pattern to the rainfall. When you look at the rift, for example, and you compare just what are the affordances in the rift as opposed to the highland, this is the mean temperature. So it's like, can be 4 degrees higher on average. And the amount of rain is a little bit lower, but it's distributed more evenly throughout the year. So there already you have some important differences in terms of the biosphere. And as I said, radiation is something that we need to look into and how it affects the biosphere. Another thing in which I think the highlands are unusual and we should train our brains to think about them, is the issue of the Afro-montane forest. This is a form of vegetation, or forms, I should say, of vegetation that occur, at least in the area we are looking at now, above 2,000 meters. So a site like Melka Wakena would be at the lower tier of the Afro-montane forest, not very populated with trees, but with a lot of shrubs and herbaceous plants. And the Afro-montane forest is a very interesting form of vegetation, and it's basically a hotspot of biodiversity. You can see here that there are islands of the Afro-montane forest along the coast of Eastern and in Western Africa. These are discontinuous areas of forest. They are called sky islands, and you can see here the graphic expression of that. These are the sky islands, and they apparently are disconnected. They're separated by low-lying areas. These are hotspots among the world big hotspots of biodiversity. And there are many models trying to explain what is happening and how this biodiversity is kept, maintained, and even increases at some points. So this can be associated with the formation of the rift and the role of the sky island as refugia that are less affected by maybe the rift directly, but how information, so to speak, or genetics travel from one island to the other is still hotly debated. You can see here two models of it, but I'm not going to go into this. And why is this interesting? First, we are in an area that is in the Afro-montane forest, although now it's so heavily cultivated that you would not know it. But Raymond Bonfil published some work on the pollen for Melka Contour, which is about 100 kilometers to the northwest of Melka Wakena. And according to her, the Afro-montane, the dry evergreen, this special lower tier of Afro-montane forest in the grassland complex already existed in Melka Kunture at 1.8 million years ago. And I'm just extrapolating from there to here. Of course, we will have to find the pollen and do our own work on this, but it does stand to reason that Melka Wakena was under the same conditions. So we are looking at an area with considerable biodiversity, as you can see here, or supposedly. I suggest that we are looking at an area with a lot of biodiversity, which would be conducive maybe for the expansion of the ecological niches of hominids and to the survival of the hominids. When you look at the paleo environment or the context of the specific localities, they are all associated with fluvial systems, but in very different channel energies. Here we see Bienvenido excavating his hippos. This is layer 4. This is right here is the bottom of layer 3, and you can see that the sediments are very different. So these are fluvial sediments. This is coarser, this is finer. The archaeology is in a layer of conglomerate that is coarse. So this is sand mixed with tephra. The velocity that each sediment represents is obviously different, and the location within the river system or within the drainage is obviously very different. I showed you before the locality of MW5 with the channel going through and redepositioning some of the bigger clasts. So that's another level of velocity of energy of flow. And at MW1, we see yet a third aspect of the fluvial system with small conglomerate. This is a larger conglomerate, the archaeological layer, small conglomerate and another big conglomerate, very nicely sorting upwards as channels would do. So basically we are all the time in the channel itself. A suggestion that the geologists have not yet turned down, I should say, is that at some point we are looking at a different depositional regime where in the upstream you still get a lot of accumulation, but in the downstream part of the site, we are looking at a landscape of erosion and refill, which would explain some of these large, very thick deposition. These are tephra in river valleys that are filling the topography, landing on the topography, and creating these huge, thick units. So a lot of changes here before 1.3, and then you can see how this kind of comes together to something that is a more feel of large, big valleys. And there's a lot of paleogeomorphology that still needs to be done, and we're hoping to be doing this in the future years, but this is a model that we would like to explore next. The fauna in the sites and around the sites and from the stratigraphic context, all the fauna have stratigraphic context that can be related to the site, to the archaeological localities, show a mixed environment. We have aquatic fauna, so we have crocodile, we have hippos, we have redancing antelopes, which are hydrophiles. They like to be near the water. So we have all these. And we have animals that are more characteristics of open and drier savanna or mixed woodland, like the equus, the giraffe, and other types of bovids and antelopes. So at least by the fauna at the sites and around the sites, we are looking at, like usual, an ecotone. A large amount of fresh water. Hippos need, and crocodiles need big rivers or big lakes. We haven't found lake sediments when we do have the big river sediments. And we have the scrub savanna with smaller drainages going through. And I think we already saw that all of these are represented in our sample. The species composition is the same, I would say, between 1.6 and 1.3, 1.35 million years ago. But the relative abundances differ, and we don't know yet, and this is the question that needs to be addressed, if you're looking at a change across the whole area, so based on the climate, change of the climate may be consistent with the suggested change in the fluvial, in the regime of the fluvial system, or maybe we're just looking at sites that are located slightly different in respect to the major channels. So, for example, MW2 is located very close to the channel. I will give a supporting argument for that in a minute. Very close to the channel. And so you see all these water-loving animals, where MW5 is a little bit off into the drier areas. So there are smaller drainages going through the site, but the fauna that is available right there is more of the dry savanna environment, even though they do have some hippos in the site. So we don't know if it's a big climate change or just a small change in the preferred location of the sites. All these things bring me to trying to say what people were doing there in Melka Wakena, on this part of the Gadol Plain between 1.6 and 1.3, 1.25 million years ago. I'll just remind you the two main periods of occupations that we have. 1.6, from which we have one site, one excavated site. 1.3, we have several assemblages, not so much fauna, and around 1 million. So we have 3 time slices to look at. 1.6 million, I think we're looking at a very large landscape occupation. So I don't know, obviously, I should say, not a single locality, not a single group, not a single occupation. We don't have the resolution for that. But when you look at the distribution of layer 3 at the site, this is Melka Wakena 2, right here. And we follow the same layer along one side of the river, where we do have deposits. And we see the same layer on the other side of the river. So a minimum estimate would be of a landscape of this size that is occupied by the Acheulian groups at that time. Probably not at one time, but this is a very large landscape that they are using. And I will show in a minute that I think it's probably larger, or at least the territory was larger. We see returns to the same locality. Obviously, there are several stratified layers, but I'm just looking at this one, and again, bear in mind the very limited information, especially for layer 4, but the nature of the occupation here and here seems to be different. So people are going to the same place, but are not doing the same thing. So maybe we should not expect similarities, even though they're close in time, similarities in the assemblages, depending on how much is decided by the function and how much is decided by other factors. So something to look at and explore here. We look at movement in the sense of carcass transport and processing. The hippos were not hunted where the people were living, or did not live, I should say, where the people were living. So the fact that we find the hippo bones, and some of them are percussed, in these areas a little bit off the main drainages, or a lot off a lake, if there was a lake, I think not in the Melka Wakena area. This is one of the hippo bones. So they were bringing parts of the animals back to a specific locality in order to process it. We already saw the distribution of the raw materials, and the fact that Melka Wakena people likely went to this area, or other areas that we may not be aware of, and this is some kilometers away, probably 8 kilometers away from Melka Wakena. I can now extend this and show you, this is our sites, Melka Wakena, this is the Gadeb. In the Gadeb, most of the indexes and the bifaces are made on cobbles and are made on stuff that was found in the rivers, but indexes on flakes are made of glassy ignimbrite. And already Desmond Clark said that this was not available at the area of the site and suggested that people left to get the raw material somewhere else. So I'm sort of suggesting some connection from the Kava localities, so Melka Wakena, this is 1 million, so we're looking at 1 million years ago, some bigger territory, longer transport of raw material from the source to one site and to another site. And how things were between two sites, who knows? But this, I think, gives us an idea of the landscape. So finally, looking at the question of the rift and the highland. And I think in the literature, going back to, I should say, in the literature, we always hear and know of the rift and the lakes of the rift as sources of resources for human occupation. Of course, there's water, and of course, these are environments that are conducive to human existence. But how was a movement between the various basins of the rift conducted? How easy was it? And we are looking here at this cross-section from Maslin et al., who were talking about the climate, something different. From the 2 degrees south to 12 north, we are about here. And they're looking at a schematized section, and the rift consists of basins and paleo basins. Some of them are filled with lakes, and some of them are now dry, but you can see that we have the basins and then elevation and a basin and another elevation. So in fact, the basins are pretty isolated, and to move from one to the other, to go north from one to the other, it's not so easy. I will also mention that the rift floor in this, here it's pretty low. Here in these areas, the rift floor is about, as we saw in some of the earlier slides, about 1700 meters above sea level. So it's pretty high. Even if you stay in the rift, you still have a lot of topography to cover if you move on a north-south axis. So a problem. Trout et al. Talked about the amplifier lakes. These are the lakes that fill the tectonically formed grabens, and they are very susceptible to high precipitation, to evaporation. They respond very quickly to changes in the climate, but not just the climate in general, but also to small, regional, local scale, because they amplify the effect of the rainfall on the highlands that feed into the lakes and so on. So the amplifier lakes are links between long-term and high amplitude tectonic processes and short-term environmental processes. They respond very rapidly to even moderate climate shifts. And when they do, they create dramatic environmental pressures to the biosphere. And whether extremely dry or whether they are filled, the basins could, at different times, obviously, act as barriers rather than be conducive to a north-south movement. So this is another thing to bear in mind. Finally, a recent model of the hydrological patterns in the rift suggests that actually under some conditions there would be incentives to move laterally, so basically east-west, rather than north-south. So this model looks at the springs and the availability of springs and how springs are connected or not connected under different conditions. So it's a model, it's not associated with any specific period. But under drier conditions, this is A, there would not be, the network of waterways, springs or rivers would not be sufficient to support long-term movements across the rift or along the rift. So there will be less connectivity between human groups. When conditions ameliorate a little bit, there would be no movement. Again, I'm not going into all the details of the model. No movement along the rift, but there could be some movement across the rift. So again, east-west. And when conditions are wet, that's when the springs are flowing fully. They connect the waterways. They are available on the flanks of the rift valley. And it says here, springs high on the rift sides may act to link rift flank rivers with water sources in the rift, facilitating transverse rift movement. So in fact, when we look at the evidence from the rift itself, there's quite a lot to suggest that going up to the highlands may not have been the worst decision that hominids could make, at least under certain conditions. Certainly, some of the sites, and now we have, I think, a third site that can support this idea and suggest that we should consider not just the rift, but the rift and the highlands as possible routes for hominids to move into Africa, but also to the north out of Africa, not, of course, diminishing the difficulties of the very accentuated topography. But then again, we have the biodiversity of the Afro-Montane area and some flatter areas that are not barred by the responses of amplifier lakes. So in fact, this could be not a bad way to move out of Africa when, for reasons that we don't really know. And I think with more questions than answers, I will leave you at that. I just want to thank all the support that we received from all these distinguished foundations for Tegenus studies, for the research in the field, and thank you all for surviving this. Thanks.